All right, so you have completed your Chapter 1 test. Now it's time for our statistics and probability lesson, and this one will be on stem and leaf plots. A stem and leaf plot is a way to organize numbers using a chart that looks like this. The stems go on the left, leaves on the right. And in order to get started, I think the easiest thing for us to do is to just build the plot together so we can see where we get our stems from, where we get our leaves from, and how we get the job done. So first thing, I've started you off with a list of numbers here. My list is not in order. Easiest way to get started with the stem and leaf plot is to put your numbers in least to greatest order, which I have done here in red. So we're going to use the red numbers to help build our stem and leaf plot. So what you want to do first is group the numbers according to their common tens place. So we got all of our ones here, ones in the tens place, all of our twos in the tens place, threes in the tens place, fours in the tens place. And go ahead and draw that symbol underneath your list of numbers. That helps us to really get a visual of our different groups. So our first group here, 14, 15, 18, 18, all of those numbers have a 1 in the tens place. That's going to be our stem. And the ones place will be our leaves. So our ones places are 4, 5, 8, 8. All we do is we take them and we write them over here on the leaf side in order with no commas separating them. Okay, our next stem is 2. Those are the 2s in the tens place, or our 20s. Our leaves are 0, 2, 2, 4, 9. Notice how I am spacing mine out, right? I'm putting my numbers directly beneath the number above it, trying to use good spacing. You'll see why that comes in handy in just a second. Our next stem are the 3s, or the 30s. Our leaves are 0, 1, 5, 6, 9. Again, I'm paying careful attention to my spacing. I'm also not using any commas. My final stem is 4, and the only leaf is 0. So this is a stem and leaf plot. When I was in school, I was like, okay, wow, well, what do we do with it? First thing we have to do is tell people how to read it. So you want to create a key. The key is not optional. You must do this, okay? The key tells us how to read our chart. So in order to do that, you write the word key and you pick any number out of the chart. I'm going to pick the number 22. And you show what it looks like in the chart, 2 on the left side, then your line, 2 on the right side, and then you tell what it equals in real life. So you only have to do this one time for any one number in the chart. You don't have to go through and do it for every single number, but you do have to help people understand how to read and interpret your chart. Okay, so now that we have our stem and leaf plot completely finished, I want to show you why we do them. What's the whole point? Because when I was in school and I learned about this, I could not wrap my head around why I cared about stem and leaf plots. Let me show you. So first thing I'm going to do here is I'm going to do a little grouping, and I'm going to turn my plot upside down, or to the side like this. When we look at our chart on its side, it almost takes on the look of a different chart. I'm going to draw some lines in here, some boxes, some bars. There we go. If we look at our chart this way, with the bars stuck together like this, it takes on the look of a histogram. So remember, a histogram is like a bar graph, but the bars touch because it's interval data. Our 1 stem would actually be the interval of 10 to 19. Our 2 stem would be the interval of 21 to 29. Our 3 stem would be the interval of 30 to 39, and so on. So that makes this a histogram because they're bars that are stuck together, and they show the frequency in each interval. So here we can see there are 4 numbers in the tens interval. There are 5 numbers in the 20s interval. There's only 1 number over here in the 40s interval. So stem and leaf have a direct correlation with histograms. Pretty neat fact. I was a lot older than you when I found that out. I was making stem and leaf plots for many years without having any clue what the reason for that was. I have one more thing to show you. We've got our stem and leaf plot here, another example for you. Here's a different key for us. This key tells us how to read the numbers in the chart. 90 equals 90%. So maybe these are test scores or quiz scores. So to read these numbers, remember we have a 6 and an 8. That would be a 68. A 10 and a 0. That would be 100. That's 100. 8 would be 88. So that's how to pull those numbers out of the chart. We can use our chart to help us find mean, median, mode, and range, and actually speeds things up a little bit for mode and for range. So let's do the mode first. That's always the easiest. Mode, if you take a look over here at your leaves, look at the leaves that are showing up the most frequency. See all this cluster of zeros here? That tells me we've got 90, 90, 90, 90. There are 4 90s in our list. That's a lot. That's the most out of any of them. So our mode is 90%. Next easiest is the range. Range, when we take the greatest, then we subtract the least. 100 minus 68 is 32%. Median is pretty easy as well. Remember, I have a trick for median. I count up how many numbers are in the set and divide by 2. So really, we're just going to count up our leaves over here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we have 18 numbers in the set. We divide that by 2, and we get 9. So that's a whole number 9. So that tells us that we will have 2 middle numbers. There will be 9 numbers in the lower half of the set of data and 9 in the upper half. So let's count that out. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to draw my line after it. Try that again. Draw my line after it. And those 2 numbers are going to be my 2 middle numbers. There are 9 digits down here. There are 9 in the upper half. So if I have 2 middle numbers, I add them together and divide by 2. If I do that, my median is 88. Last but not least is the mean. Nothing really helpful about the mean with stem and leaf plots. We still have to do all the footwork, adding everything up and dividing by how many numbers there are in our data set. So I did this work ahead of time. If you add up all those numbers, you get 1,456. And there are 18 numbers in the set. If we divide 1,456 by 18, we get 80.8 repeating, so I'm going to round that to 80.89%. Okay, so doesn't really help us speed things up for the mean, but it might help a little bit for median and mode. Okay, that's stem and leaf plot. If you have any questions, make sure you ask about them in class.